Continuing on with our discussion on motion along a straight line, let's now take a look at the concept of free fall motion. Free fall motion is a continuation of our discussion on uniform acceleration. It is basically vertical motion with gravity as the only source of acceleration. You have an object moving along the vertical axis, so the motion is limited along the y-axis. The object may be moving upward or it may be moving downward. And the only acceleration is acceleration due to gravity. So A is equal to G, and G is always heading downward, heading towards negative y direction, the negative direction. So G is equal to negative G. Negative because downward, negative direction. And G is the magnitude of acceleration due to gravity. And this is constant. You have uniform acceleration. As such, you have the four equations of uniform acceleration. But in this case, A now is G, acceleration due to gravity. And instead of X, we have Y because the object is moving along the Y-axis. So you have V is equal to V naught plus GT. Y is equal to V naught T plus 1/2 GT squared. V squared is equal to V naught squared plus 2GY. And V average is equal to V plus V naught divided by 2 is equal to delta Y divided by delta T, or simply Y over T. Now, for locations on or near the surface of the Earth, the acceleration due to gravity is given by negative 9.8 meters per second squared. And this is constant. The acceleration is constant at this value as long as the object is on or near the surface of the Earth. Let's now have the following example. Sample problem number 1. A pitcher on the ground tosses a baseball vertically upward with an initial speed of 12 meters per second. You are asked for three things. How long does the ball take to reach its maximum height? What is the velocity of the ball when it reaches a point 5 meters above the release point? And what is the velocity of the ball when the pitcher catches the ball? You have an object that is thrown vertically upward, so it's moving along the y-axis. The only source of acceleration is gravity, so A is equal to G automatically, equal to negative 9.8 meters per second squared, and it is constant at this value. So you have an object moving in uniform acceleration. You have the four equations of uniform acceleration that you can use to analyze the problem. The pitcher throws the ball with an initial speed of 12 meters per second, so throws it vertically upward. So the initial velocity is positive 12 meters per second. First question, how long does the ball take to reach its maximum height? So we're being asked for time t, time to reach the maximum height. Now, for an object that has been thrown upward, the object is moving upward, but the acceleration is downward. The object will be decelerating. It will slow down as it moves upward, eventually reaching zero velocity, at which point the object has reached the maximum height. So at the maximum height, the final velocity is 0. So from 12 meters per second, the object slows down to 0 velocity. Now, again, this is uniform acceleration. You have the 4 equations of uniform acceleration that you can use to analyze the problem. Using the first equation, v is equal to v naught plus gt. If you look at the known values, we know final velocity v, we know v naught, and we know g. The only unknown is time t. Isolating time t and plotting in the known values, we are able to calculate the time of travel it takes to reach the maximum height. T is equal to 1.224 seconds. Going now to the second question rather. What is the velocity of the ball when it reaches a point 5 meters above the release point? Taking the release point as the origin, so y is equal to 0. The point we are concerned with is 5 meters above 0. So final position, we let y be equal to 5.0 meters. Positive because above the release point, so positive direction. The displacement is positive direction. Going back to our list of equations for uniform acceleration, if we look at the second equation on the list, y is equal to v naught t plus 1 half gt squared, transferring y to the other side, and multiplying the whole equation by 2, we get gt squared plus 2v naught t minus 2y is equal to 0. Plotting in rather the known values, we get negative 9.8t squared plus 24t minus 10 is equal to 0. We have a quadratic equation. If we use quadratic formula to solve the quadratic equation, we get two answers. T1 and T2. T1 is equal to 0.53241533078 seconds, and T2 is equal to 1.916564284 seconds. The two values are positive, meaning they are both valid values for the time of travel, which means the object will reach the 5-meter mark twice, T1 and T2. Again, using V is equal to V naught plus GT, if we plot in the two values of time, we get V1 6.782329984 meters per second. And if we plot in T2 into the equation, we get V2. V2 is equal to negative 6.782329984 meters per second. So the two answers for velocity at the 5-meter mark, V1 is equal to 6.782 meters per second, and V2 is equal to negative 6.782 meters per second. Notice that magnitude-wise, they both have the same value, 6.782, but one is heading in the positive direction, the other one is negative, heading in the negative direction. This illustrates one property of an object that has been thrown upward. The object passes through a given height twice on its way up and on its way down. When you compare the velocities at the 2 points, going up and going down at the 2 instances rather, if we compare them, they are equal in magnitude but opposite in direction. V up is positive, V down is negative. So in this case, V1 is V up, whereas V2 is V down. V down is equal to negative V up. This property gives us the answer to part C of the problem. What is the velocity of the ball when the pitcher catches the ball? Same level, initial level, hand of the pitcher. The ball goes up, then goes down, the pitcher catches it. So, same final position as the initial position. Same level. If the ball leaves the pitcher's hand with a velocity of positive 12 meters per second, the ball will reach the pitcher's hand with the velocity V catch negative 12 meters per second. Negative 12.000 meters per second. Let's have one more example. Sample problem number 2. You have a student. He drops an egg from the roof of a building. Several floors below, another student sees the egg through a window and determines the speed of the egg to be 25 meters per second. What is the distance between the roof and the window? Again, we have an object undergoing vertical motion, and the only source of acceleration is acceleration due to gravity. So A is equal to G is equal to negative 9.8 meters per second squared, and it is constant at this value. The egg is dropped from the roof of the building. So the initial velocity of the egg is 0. The object undergoes free fall motion, acceleration is equal to G, travels distance Y, a window several floors from the roof, below the roof. There is another student and he sees the egg, determines the velocity, the speed of the egg is to be 25 meters per second. The egg is still moving downward. So at this point, the velocity of the egg is negative 25 meters per second. Let that be the final velocity V. Now, the object travels distance y downward, so displacement y. The distance between the window and the roof, let that be h. Y is equal to negative h because y is downward. H is length. H is magnitude of y, so y is equal to negative h, and we are looking for h. So once again, this is uniform acceleration. If we take a look at V is equal to V naught, V squared is equal to V naught squared plus 2GY, and we take a look at the known values. We know V, we know V naught, we know G, the only unknown is Y. So plotting in the values and isolating H, we get the answer for H. H is equal to 31.888 meters. And that's it for now. In the next video, we'll take a look at the concept of projectile motion. So thank you for watching.